Okay, we're going to be talking about fractional addition today. So, a few different rules here. When adding fractions, you must always have common denominators. The number that refers to the number of pieces we have, and therefore the size of the pieces, that has to remain the same. And when we add fractions, if they both have the common denominator, in this case we're using just letters to represent the numbers, if they are the same, then you add the numerators. That's the simplest way to say that we can add fractions, and it's not very tough to add them if the denominators are already the same. The problems with adding fractions come when we don't have common or same denominators. We'll see how that impacts us later. But what does this look like with numbers? Let's say I want to add 5/8, meaning I have 5 pieces that it takes 8 parts to make a whole, 5 in the numerator and 8 in the denominator. And I want to add to that 1/8, one piece out of something that takes 8 to make a whole. Remember, if 8 is the denominator, that means it's going to take 8 pieces to make one whole. And to add these, we're just going to imagine, what if I combine them together and add 5 plus 1? Well, 5 plus 1, if I move that 1 over, that 5 plus 1, if we imagine that 1 changes, now we have 6 pieces. 5 plus 1 is 6. I have 6 out of 8 pieces now. Now, some of you that have already worked with fractions before know the next step I should take. 6 over 8 is not yet a completely correct or proper answer. We need to remember that in fractions, we like to think of the biggest possible pieces I can. So if I imagine that I can group these into pieces of 2, I could group it so that there were only 4 parts, and if I did, then I would have exactly 3 out of 4 of those parts. That's really what we call reducing or simplifying. I look at the number 6 and 8 and I ask myself, what is the largest number that goes into both of them? And that number is 2. So I divide both 6 and 8 by 2. 6 divided by 2 is 3. 8 divided by 2 is 4, which is the same thing as if I had 3 larger pieces where it only took 4 to make a whole. So we must always reduce. Now, some students often ask me, Mr. Bryan, how long am I going to reduce? When do we get to stop doing this? And the easiest answer I have for them is, you will do this for the rest of your life. So just get used to it. We always have to reduce. That's just something we always want to do. So there are 4 steps to adding fractions. This is a point where I would say you might want to pause the video after I get these up, because I'll probably talk through these quicker than you can write, but that's the nice thing about pausing. Now I'm actually going to start with step number 3, which is, if the denominators are the same, add the numerators only and leave the denominators the same. That's what we just did. The reason it's step number 3 is because when the problem gets harder, we actually have to do things first. Before I add them, I need to change them. So if we come to a situation where the denominators are different, I actually have to convert the fractions to be what we call equivalent fractions, meaning fractions that mean the same thing, but they have different numbers. Okay? So I need to do that. Then I can add them. Once I make sure the denominators are the same, I convert them, change them around, then I can add them. But sometimes we actually end up with mixed numbers, and we need to actually convert those first to improper fractions. Then we can add or convert the denominators before we add. So adding fractions, really simple with common denominators. But if we ever find a situation where they're not the same, we actually have to do some preparation to get them ready to add. And then, of course, at the end, we would reduce and maybe even convert it back to mixed numbers like we learned about in the last video. So let's take a couple examples. We're going to look at one example that's like number 2 with with different denominators, and then we'll look at one that has mixed numbers in it. Again, now would be a good time to pause if you're still writing these things down, and I'm going to move on now to some examples. Okay, let's say I want to add 3 out of 4. 3/4 means 3 pieces I have out of something that takes 4 to make a whole one. I want to add to that 1/8. We see the sizes of the pieces are different. Now, that's why it's a problem. If you were talking about pieces of pizza, somebody's not going to be happy if they get the 1/8 and everybody else gets the one of the 3/4 pieces, because they would get less pizza. We want all the pieces to be the same so that we can think of them the same. Now, to do that, I might need to imagine 4 and 8 and say, well, what could I cut these up into different sized pieces so that they were the same? And if I do that, if I think of 4 and 8, what I'm really looking for is the lowest common multiple. The lowest common multiple between 4 and 8 is the number 8. So I need to change 3/4 into a fraction that has 8 in the denominator. So I ask myself, 4, how do I make that into an 8? Well, that's 4 times 2. And then in order to do that, if I want to get eighths, 4 times 2 is going to give me 6 pieces, because I multiply each of the 3 pieces times 2 as well. So I've converted those 3/4 into 6/8. I'm going to take that, I'm going to add it to my 1/8. Let's move those together, combine them up, and add them together. Move that 1 over. Add 6 plus 1, which is going to be equal to 7 total pieces. So I have 7 out of 8 pieces, 7/8. Don't forget, we always reduce if you can, but sometimes you can't. This is a case where there's no number that can divide into 7 over or 8 equally. Okay, so 7/8. Don't forget, convert denominators before you add. We never just add the denominators. It's not 4, 3 plus 1, 4 over 4 plus 8, 12. That's not what adding fractions is all about. Now here's another one where we're going to be adding fractions with mixed numbers. Now, apologize, there's a little something wrong with my presentation here. We got the answer already, but that's okay. We can see where we're going. Our answer is going to be something about 21 over 8. But on the left, 1 and 1/4. So I have 1 whole plus 1/4 of that, and I want to add to it 1 and 3/8. So I have another whole, but 3/8, something different. Now, this gets us into a little bit of a trick. What I want us to do is first imagine that those whole numbers are pieces, that we can divide those up. So remember, switching from mixed numbers back to improper, I actually take the 1 and 1/4, I take the denominator of 4 and I multiply it times the 1. Well, 4 times 1 is 4. And if I take those 4, add the piece there, I end up with 5 pieces on the left there, you can see. And if I do the same thing on the right, 8 times 1 in the whole number gives me 8 pieces. And then I remember, add the 3 other pieces I have and count it up, I end up with 11. So what I really have is 5 over 4 plus 11 over 8. Instead of thinking about mixed numbers, I want to think in the parts, because that's how I'm going to combine them back together. Now, are my denominators the same? No, they're not. My pieces are different. I have 4ths and 8ths. I need to convert them. Now, in this case, we can convert the 4ths. I can multiply them by 2. We want to get them all in 8ths. I recount them up. I actually have 4 times 2 is 8. 5 times 2 is 10. I have 10/8 plus 11/8. I now am looking over on the right side. All of those mixed numbers and different fractions, I can ignore them now. I've moved past that, and now I add 10 plus 11, which, as we saw earlier, we know is already 21. We get 21 over 8. That's not my final answer. Remember, we don't want to leave it in just a bunch of pieces. We want to convert that improper fraction back to a mixed number. So I divide 8 into 21. 8 goes into 21 2 times. Okay, so I can really make 2 whole parts out of the 8 and write that as my whole number. And what I'm left with is 5 pieces. Remember, it's the remainder 5 over still the size of the pieces, 8 for my denominator. Check if I can reduce. 5 and 8 can't reduce anymore, so that is my final answer. But remember, follow those steps in order. If you're still not sure how to switch between proper and improper fractions, or you're not quite sure how to convert the fractions to find a common denominator, if that's something that you struggle with, make sure you ask me for help, or go find some extra help online. Ask a parent or an older brother or sister or cousin to help you, or go find some videos on some sites that explain that in a little bit more detail, and you're going to be doing some practice on this on your own.